All right, we're taking a look now at the second half of lesson 2.7, talking about parallel lines. Now, if lines are not parallel, that means they're going to intersect somewhere. Parallel lines means that they will never intersect, but it also means they're in the same plane. They're on the same flat surface, so they're never going to intersect, also in the same plane. In your book or on the notes or anywhere that it wants to designate that two lines are parallel, they will usually put a arrow or a triangle, little triangle, on the line itself. That's a way of showing you these lines are truly parallel. They don't just look like it, they are parallel. They would never intersect. If they continued on forever in either direction, right, they would never intersect no matter how far out you went. Okay, that's what parallel lines means. Another way of showing that lines are parallel is sometimes they will have, let's put a name, say this is line M and this is line N. Sometimes they'll just say M is parallel to N. So if they don't have the little arrows on it, they'll tell you somewhere in the directions that those lines are parallel. Okay. Skew lines are very difficult to show you in a diagram in two-dimensional space, because skew lines are, they're never going to intersect, but they're not parallel. Okay, and a lot of times people go, how is that possible? Well, you need to think three-dimensionally. Okay, so let's say you're looking at a room. Okay, and I'm going to draw a box to represent a room. Okay. Okay, now, if you were looking at this corner of the room here, right, and imagine that edge continued on forever in both directions, and then you were looking at this corner of the room right here. Imagine its line going on forever in both directions, up and down. This one's going this way and this way. On my paper, they would intersect, because if I drew this, eventually it would hit this over here. But since it's a three-dimensional space, they would never run into each other, because this one's going this way, this one's going this way. They're not headed towards each other, but they would not be considered parallel because they're not in the same plane. They're not in the same flat surface. Okay, that's what skew lines are. But now, back to parallel lines. If you have parallel lines, okay, like this, and they're cut by a transversal, then something becomes true. If the lines are parallel, something becomes true about corresponding angles. Let me give you one example of corresponding angles, 1 and 5. If the lines are parallel, and I keep saying if the lines are parallel because that's the most important part. If the lines aren't parallel, this is not true. But if they are parallel, the corresponding angles are always congruent. Okay? Always congruent. That means they're equal in measurement. So angle 1 would be congruent to angle 5. Okay? We would also know, because 2 and 6 are corresponding angles, we could also say angle 2 is congruent to angle 6. We could also say that angle 3 is congruent to angle 7. And we could say, orange here, 4 is congruent to 8. Okay? So corresponding angles would be congruent if the lines are actually parallel. Okay? Now, if the lines are parallel, again, something else becomes true about alternate interior angles. Alternate interior angles will also be congruent. That means that 3 would be congruent to 6. That also means that 5 would be congruent to 4. Okay? Because alternate interior angles are congruent if and only if the lines are actually parallel. The third one, if two parallel lines are cut by a transversal, if the lines are parallel, if and only if, something becomes true about alternate exterior angles. They also are going to be congruent. So that means that angle 1 and angle 8 would be congruent. And that would also mean that 2, and I'm going to put 2 lines here because I've been using these colors, but if you get to the book or if you get to a paper, a way that they will show the angles are congruent is not just by the colors of it, especially if it's all in black and white ink. They put two arcs to refer to ones that are the same measurement. So angle 2 would be congruent to angle 7. Okay? Finally, our last pair of angles that we discussed was consecutive interior. And if the lines are parallel, if and only if the lines are parallel, the consecutive interior angles are, I hope you remember this word, supplementary. Supplementary means that they add up to be 180 degrees. So that means that angle 3 and angle 5, not congruent, angle 3 and angle 5 are supplementary. Or you could say the measurement of angle 3 plus the measurement of angle 5 equals 180. You could also say 4 and 6, so we could say the angle 4 and angle 6 are supplementary. Another way we could say that would be the measurement of angle 4 plus the measurement of angle 6 equals 180. Now, to put this into practice, if angle 5 equals 72, where's angle 5? There it is right there. Angle 5 is 72 degrees, okay? Find the measurement of angle 4. Well, angle 5 and angle 4 are corresponding angles. One's inside, one's outside. The lines are parallel, right? See the little arrows there? Lines are parallel. So 4 and 5 would then be congruent to each other. So if angle 5 is 72, then we would also know that angle 4 would equal 72 degrees. If angle 5 is 72, now angle 5 and angle 2 are alternate exterior angles, right? Alternate exterior angles were congruent, if you look back in your notes. So that means that 2 would also equal 72 degrees. Okay? In fact, you could also say there's one more angle there that would equal 72, and that would be angle 7. And this isn't a question, but if it did say, what about angle 7? It would also equal 72 degrees, because 5 and 7 are, oh man, I wonder if you remember the name of these. Do you remember what those angles are called? No? You should look back in your notes. They're called vertical angles. Vertical angles are always congruent, no matter whether or not the lines are parallel. These are vertical angles. So this would also be, so angle 4 in relation to angle 5. Angle 4 is, those are corresponding. Angle 2 was alternate exterior. And angle 7, vertical angles, in relation to angle 5. Now it throws in here at this bottom, this extra practice here, angle 8 is 105. I'm going to actually change this and ignore this for just a second. Let's actually go up here and say, well, what then would these other angles be? 1, 3, 8, and 6. Well, if this is 72 right here, let me go back to the red. If this is 72 degrees, and this is 72 degrees, and this is 72 degrees, what about these other ones? Well, there's a lot of ways you go at it. A linear pair of angles, that's angles that are right next to each other, are supplementary. So you could say that 8 is 108. Right? Or you could say consecutive interior angles are supplementary. So 4 and 8 are consecutive interior, they're supplementary. 108 plus 72 is 180. In fact, you're going to find this pattern to be true in all of these. If you know one angle, you can find all of the angles if the lines are parallel. Right? It's kind of like a checkerboard pattern. Right? 108, 108, 108, 72, 72, 72, and 72. This pattern will always be true. You will see this every single time. Okay? Well, there you go. There's the lesson. Your assignment, if you're in class and you're wanting to know what your homework assignment is, it would be to do 1 through 14. We'll do the other ones on a different day, but this will get you started making sure that you understand what to do with these problems.